Welcome to Kenton's videos. Enjoy the video.
In this video, I will compare copper bush versus needle bearings. We'll explore their fundamental designs, operational principles, and typical applications. You'll learn about the key factors that differentiate these two common bearing types, helping you make informed decisions for your engineering projects. We'll cover aspects like friction, load capacity, and maintenance requirements, providing a comprehensive overview of their respective strengths and weaknesses. Copper bush bearings, also known as plain or sleeve bearings, are incredibly simple in design. They consist of a cylindrical sleeve, often made from bronze or brass, which are copper alloys. These bearings operate on the principle of sliding friction, typically requiring lubrication to reduce wear and heat. They are highly cost-effective and perform well in applications with oscillating motion, moderate speeds, and where space is limited. Their robust nature also allows for good shock absorption. Needle bearings are a type of roller bearing characterized by their long, thin cylindrical rollers, resembling needles. This design allows them to handle very high radial loads within a remarkably small cross-section, making them ideal for compact assemblies. They operate with rolling friction, which is significantly lower than the sliding friction found in bush bearings, leading to higher efficiency and less heat generation. Needle bearings are often found in automotive transmissions and engine components due to their high performance. When comparing the two, needle bearings generally offer superior load capacity and lower friction, making them suitable for high-speed and heavy-duty applications where space is at a premium. Copper bush bearings, conversely, are more economical, simpler to install, and can tolerate dirt and misalignment better. They are often chosen for applications involving oscillating motion, lower speeds, or where shock loads are present. The best choice ultimately depends on the specific operational requirements, budget, and environmental conditions of your project.
Thanks for watching. Consider subscribing if we helped you.